So, till this particular module we were actually been talking about the different kinds of tools that penetration tester could typically make use of for doing the test the attack test from the server side or from the client side or from an authentication point of view or over the web, right. If you see all these individual modules that we had till now has always been from the perspective of the penetration tester or the attacker, and what kind of tools he could make use of, which are actually available in Kali Linux by default, or he could potentially download those tools also and then install it on Kali Linux and then subsequently make use of it. So, in this module we are basically going to be changing our viewpoint from the point of view, moving away from the point of view of the penetration tester to the point of view of the network administrator or the security administrator of that particular organization, which the attacker is actually trying to penetrate and then see if any potential targets could be compromised in that particular network. So, we are going to basically see from the perspective of the administrator of that organization or the network, what kind of typical countermeasures from a defensive point of view that he can take, so as to basically make sure that the efforts of the penetration tester or the hacker is not successful, and he comes to know of the attack, imminent attack that is possibly going to happen before the penetration tester is successful in his attempt. So, we are going to basically see from the policy perspective or the guidelines from the guidelines perspective, what kind of measures that typical administrator would need to take care of. So, as a defensive countermeasure, basically organizations put their trust in sort of installing solutions that they hope will provide sufficient defense from any kind of a cyber threat that their organization could be subjected to. Now, as part of this effort, typically if you find the network administrator would basically have procured products from the market, basically commercial off the shelf products that is actually available in the market, and then sort of installed it in their network, maybe a firewall or an IDS or any of those kind of products, and then install it in their network, and they are hoping through that installation that their entire network would actually be provided sufficient insurance against any kind of a cyber attack by a penetration tester, right. It is given that for the sake of their business continuity, the vendors from whom these particular customers would have actually bought the products from, the security products from, would definitely offer the protection, right. But beyond a particular point in time, as most of us would have actually experienced by ourselves, the vendor would not be the customer could not basically have the vendor beyond a certain liability sort of an insurance given for any kind of an attack that the customer might be facing, right. It is only to a certain extent that the vendor would actually take up a liability clause for any kind of problem that the customer is facing even after the installation of that particular product, right. If you actually have installed any kind of a product, first time when we actually try to open up the let us say the administrative management screen or try to bring up the product or whatever it is as appropriate, we will actually be exposed to a huge license agreement that we as an end user would be asked to accept it before even the product is actually started up for the first time, right. So, almost all of us would have actually faced this in some form or other, and if we actually spend some time which most of us do not generally do, if you actually spend some time in reading through the fine print of each and every line in that license agreement, the end user can very easily see that the vendor is basically sort of giving out a statement that he or she should not be held liable for any kind of mishap that could happen in the organization's network even after the installation of that particular product which is supposed to be actually securing the network, right. What kind of problems could possibly happen? It could just be a sort of a missing update. So, for example, you have a Windows 10 operating system installed on your PC, and let us say that there has been a vulnerability that has actually been found out on that particular Windows 10 OS. Microsoft might be possibly coming out with an update to address that vulnerability, but as an administrator one could have actually postponed that update installation of that particular update on that PC maybe by a couple of days, right. So, in that particular time frame window of those 2 days, for example, if the attacker basically tries to find out that vulnerability is still existing in this particular system, the attacker could possibly make use of that, right, or it could be a simple configuration error, right. So, what could be a configuration error? Sometime back we would have heard that a simple DNS misconfiguration that has actually been done in one of our neighboring countries basically led all updates, all redirections of the website youtube.com into that particular wrong server, which was actually not youtube.com, right. So, likewise we keep hearing different kinds of problems that has actually arisen because of the fact that there was a configuration error that was actually done, or it could be actually any kind of a breach that the vendor himself would not be actually could be made as a party for being liable to be given to give protection to the customer, right. Now, in addition to all this problem which could potentially happen within a single vendor solution, typically speaking, if you see in any organization network, we never have products all coming out from a single vendor, right. So, it is always a multi vendor set of solutions that is actually installed in a typical network, wherein it basically becomes easy for each of those vendors to just point a finger to the other vendor in case there has been any problems that has actually get reported, which has been actually leveraged by the external attacker also, right. So, essentially leave alone the problem not getting solved and the business getting suffered because of that vulnerability getting abused, one cannot really go and basically have the liability clause executed against each of the vendors, because they will actually be just pointing fingers at each other, right. So, essentially these are the different practical problems that actually happens in a customer situation when we as an administrator basically try to have different products installed with the aim of protecting the entire network. So, in this regard again we will go by a quote of Sun Tzu from the Art of the War book. If you remember, we had actually when we started off talking about Kali Linux in one of our earlier sessions, we again had a reference of a quote from this particular author. So, again as we come towards the end of this particular part of the course, we will again quote one more quote from the same author. If you know the enemy and know yourself, you need not fear the result of 100 battle, right. If you know yourself but not the enemy, for every victory gained it is guaranteed that you will also suffer a defeat, right, maybe in the immediate next battle, right. Or if you know neither the enemy nor yourself, you will basically keep succumbing in every battle that you are forced to fight, right. So, likewise the same concept is actually very true, especially when we are dealing with the penetration testing. So, that is why in Kali Linux we always say that we know yourself and we know your weakness, right. This is something which actually has to be sort of always kept at the back of the mind whenever we are actually trying to have defensive countermeasures installed to such an extent that we want the entire network to be protected against any kind of a cyber attack. So, what could be the different parameters that as a security or a network administrator one has to basically be looking at, right. One of the basic things that is required as a countermeasure is that we need to actually have all our systems completely hardened, right. Now, what exactly do we mean by hardened here? So, when we say hardened, we essentially mean that none of the functionalities or features that is not required for our specific use will be available in the systems, right. First and foremost, we will actually try to have those features fundamentally removed from running on that particular system or the node, and even if they are actually part of my build of the image that is running on the system, we will actually ensure that they are never brought up at all, because any kind of unnecessary service that is being brought up, we have seen so many tools that an attacker could actually make use of to basically see if any one open port could be leveraged by him or her to sort of penetrate into the system successfully, right. So, by hardening, what we exactly mean is that we identify what are the exact set of features that is required, we ensure that the images that are there on each of the systems in our network is running only that functionality or only having that functionality. Even if they have other functionalities that are not required, we ensure that we do not really start up those functionalities, because that could potentially open up a loophole that the attacker could possibly exploit, right. So, that is basically what we refer to as a hardening process. Now, some of the very key parameters that one need to consider while basically developing a strategy for testing any kind of external attack possibility is that what kind of testing we are going to do. So, we basically had talked about earlier about a black box testing, white and a grey hat approach, right. And second parameter is, are we going to basically test a copy or the real system, right. So, because if I basically have a virtual environment and test it out, even if I am basically going to do some very regressive test like a DOS test or DOS attack or whatever it is, since it is basically not the live production environment, even if that particular virtual environment, that is basically a copy of the original environment, cracks down, my business will not actually suffer, right. So, the third parameter is what kind of risks I expect as an administrator from this penetration testing, and whether can I afford those risks with respect to and comparison to what I am going to be basically getting as the results of the penetration testing. Then finally, the fourth parameter of who should be informed, right. This is actually very important because penetration testing is actually something that one will not really have all the results communicated outside, right. Now, why is that? Because in most of the situations you will find that if the results of the penetration testing is actually communicated outside, even before the administrator has got a chance to plug that loopholes that this penetration testing has actually found out, there could be potentially an attack that could be actually happening onto that particular system, right. In most of the cases you will find that the final test report of the penetration testing is not divulged out in a public format, but only given to some very important stakeholders who will then have the possibility to actually have those findings, whatever are the vulnerability findings that has actually been exposed as part of the testing, all those vulnerabilities to be getting fixed at the earliest. And next parameter is, are we testing detection and response to threats or focusing on just identifying the vulnerabilities. So, if you recall, when we started introducing the penetration testing, we actually clarified the differences between these two parts, and then it helped us to understand basically how these two are different. So, that is again next parameter based on which that the testing scope will actually be decided, and also what kind of defensive countermeasure the customer needs to adopt. And then last parameter being, are there any kind of a compliance standards that needs to be looked at for the penetration testing effort. So, this again is actually very specific to that particular business segment which that customer is actually falling in. Based on these parameters, we try to come up with some sort of a baseline security mechanism that will actually we will try to cover as part of doing the penetration testing, right. This baseline security will result in trying to come out with what is the minimum acceptable level of security, which is actually like as per that particular industry segment the customer is operating on, right. So, for example, if you basically talk about any kind of a financial company like an insurance company or a banking company or whatever it is, they actually have certain standards like what is referred to as a PCI DSS standard, which is something that is mandatory for them to follow, and that basically becomes a sort of a baseline security that any kind of a testing will try to find its conformance to, right. So, they will basically go through the different requirements or the parameters that needs to be satisfied for having the successful compliance to this particular PCI DSS standard, right. Similarly, if you look at the healthcare environment, there is a different standard called HIPAA, Health Insurance Portability and Accountability Standard, which basically talks about different kinds of parameters which needs to be taken care of for protecting all kinds of medical records of the patients, because these are to be treated as strictly confidential, and because of this particular requirement they should not be subjected to attack with which the attacker could possibly extract all the confidential patient records of their health. If you look at an organization which is basically in the healthcare industry, it is very much necessary that for the baseline security parameter we take into account what are the security standards as proclaimed in HIPAA to ensure that they are at least minimally compliant to that basic set of standards in HIPAA, right. So likewise, depending on different industry segments, you could potentially have different types of security standards that needs to be followed at a minimum, and depending on the particular customer in that particular segment, the customer would have a requirement also to have more compliance to security, much more than what these standards basically ask for compliance, right, but that is something which is very customer specific, right. So there is a security technical implementation guide which is typically followed. It is basically a sort of a procedure by which a set of guidelines are actually given for different types of computer hardware and software, right. So in case any particular hardware or software is actually made use of in a typical network, what are the different security related parameters that needs to be taken care of while installation and while doing the configuration of that particular system. STIG is basically a set of standards which is basically very extensive as well, and these have actually been heavily used by the US Department of Defense as well, right, because this is not something which is very specific to one set of hardware or one set of hardware or software. It basically encompasses a huge range of applications in terms of like from the hardware, software, in terms of the operating systems, in terms of the different kind of applications that could run on that OS and so on, right. This is something which actually could come in handy to ensure that all basic vulnerabilities are actually addressed by following the guidelines for as given in the STIG standard. So you could actually have the STIG guidelines downloadable from this particular URL stigviewer.com/stigs, where you will find an extensive documentation, one document for each of the different types of hardware, different types of OS, different types of applications. Like for example, if you want to know for a typical web server what kind of hardenings are required to be done in order to make it as safe as possible and protect against most of the attacks that could be done by the attacker, you have actually got a separate document as a STIG document, a guideline document in this particular website, right. Likewise, the kind of documentation that has actually been put in for the different kinds of hardware, OS, software requirements is very phenomenal here, which is actually sort of mandatory for any kind of a government organization IT setup in US. What kind of things could actually be done by the administrator in terms of defense countermeasure? One could be the patch management, right. Nowadays we find that from the time a vulnerability is actually been found out, exposed to the time the vulnerability is like sort of exploited, there is actually a very small duration, if not what is called as a 0 day. So the moment I have a vulnerability reported in the morning, in the evening we actually find out that we have already got news items saying that a few systems in the entire internet has actually been attacked, sort of exploiting that vulnerability, right. So in this kind of a very demanding situation, it is very much essential that a very robust patch management mechanism is actually adopted by the administrator in terms of like patching the operating systems, patching the specific software applications that has been installed on that OS and so on, right. This basically becomes something which is absolutely essential in order to do it in a very quick manner, so that any kind of a small window in which the potential attacker could also exploit is completely plugged in by this kind of a robust patch management, right. This is one measure that the administrator will always be advised by a security consultant to ensure that they do not do or procrastinate installing any kind of latest patches, especially the patches related to security vulnerabilities. The next thing that will be sort of enforced or recommended very strictly by the security consultants is that on the password policy management. So when we were talking of different type of tools on the client side and the server side attacks, we are actually seen a few tools that are used for sort of cracking the passwords, right. In order to make sure, as we had seen with few examples, for the tools to be not successful in terms of quickly cracking the password, even if it cracks the password, for it to take a very long time for sort of giving time to the administrator to realize that something like a dictionary attack or a password cracking attack is actually happening right now, right. So that is basically the intent behind having a very robust password policy. Now most of the times the users, whether it be the end users of a typical server or a web portal or whatever it is, we always would want to actually have only very simple passwords that we as human beings could very easily remember, right. But most of the times we do not realize that if we can remember very easily a password, a tool that is actually running in an automated manner could actually remember that password much more easier than possibly most of us, right, because it is going to actually have a database of very commonly and very easily configured passwords with which it is going to do an attack and then see if the password can be cracked, right. So although it is a tendency of a normal human being to actually have the password very simple, most of the times we find the servers or the web portals basically enforce very strict guidelines and does not accept a password which is actually very easily crackable, right. So you find that the passwords policy are sometimes very strict, wherein it has the guidelines of saying that the same password cannot be used for more than 90 days in continuity. It does not basically permit, for example, any of the last 5 passwords to be used when you reset the password after 90 days, right. It basically enforces a length of at least 12 characters, because if I have shorter character password, since the number of permutations and combinations of the shorter length of characters is much more smaller, which makes the cracking of the password much easier. We find that most of the times the password enforcing mechanism basically tells that you cannot have anything less than 9 characters or 12 characters as the length of your password, right. And then also have certain minimal special characters like a punctuation character, or have one at least uppercase character or one number, and different combinations of this possible, right. So unless and until you give a password string which matches all these guidelines that has been enforced in that server or in that web portal or whatever it is, you are not going to allow to be change the password, right. So we should understand that all this is actually being done to ensure that our own data and our own security is protected by doing this kind of an enforcing and sort of preventing us from actually keeping a very simple password. Then the next thing that one has to take care of is we should actually try to mirror the environment and do the testing, right. So in these worlds of the VMware and the Oracle VirtualBox, setting up a virtual machine is something which has become a child's play, right. So it is no more a very complicated process, but it is just a click of few buttons by which we can actually have a replicated virtual machine set up in just a few minutes time, which is actually will give the impression to the end user as if he is really working on the native operating system itself, right. So it will always be preferable to set up a virtual environment and then sort of mirror the tools that is actually used in production environment on that virtual environment, and then use that for doing the testing, rather than basically having the actual penetration testing, especially the regressive penetration testing like the DOS test and all that done on the real production environment. So we also had actually seen quite a few tools in our previous sessions which could actually be very quickly and very easily used to do a complete clone of our web portals, a complete clone of our directory structure and so on and so forth, right. So you might remember tools like the Darebuster and all that, which we actually could potentially make use of to understand how our directory tree is and what kind of things we need to take up for cloning purposes and all that all those related tools. Now the next important thing that we will actually have to understand is the man in the middle attack defense. So we actually a few sessions before we had actually talked about the man in the middle attack. So we had actually seen different type of tools that a penetration tester could actually make use of, like the MITM and so on. Now one of the ways by which MITM could be sort of defended is to ensure that all our websites are actually making use of the 3.0 version of the SSL TLS protocol. So that is basically one deterrent, and then another type of a countermeasure that we could actually do is always ensure that we use only secure HTTP rather than the normal HTTP, which basically makes it little bit more protected by having the entire traffic encrypted before sending down on the wire. Another very important test that one has to do is to ensure that that HTTP session is set up properly, is to make sure that the certificate that is actually used for exchanging between the browser and the web server typically is actually signed by a certificate authority, and it would be more preferable for the certificate authority to be a well known certificate authority rather than somebody else. So, all these kind of mechanisms will help to ensure that the entire set of systems in the network which is possibly running things like a web server are all protected against man in the middle attack. Then finally, defense countermeasure for something like a DOS attack. So, we actually saw a few sessions before on how something like a DOS or a DDoS attack could actually be done by the attacker. This is possibly one of the most destructive testing that could actually happen, because one part or more parts of your entire network, be it your individual systems or main servers or whatever it is actually going to come down as part of this attack if this attack has been made successfully, right. So, one form of countermeasure that is typically used to have a protection against these kind of an attacks is to have larger end machines which could actually handle more packets that could be getting generated and then sent without that particular server going down, or also alternatively to very quickly determine any kind of an anomalous behavior, right, including the traffic pattern. So, what we mean by an anomalous behavior is that if we find that beyond, for example, a certain threshold level, if we continue to get the same type of a packet from the same server within a particular small unit of time, duration of time, this is something which is classified as an anomalous behavior, right. So, again one extended intelligence that has actually been added today in most of the products is that there is a certain amount of comparison which is actually done with respect to the behavior of that particular machine from which this traffic is getting generated as what has been done in the past, right. So, if I know that for the last 6 months I have actually been getting a very sane amount of packets that has been getting induced by one particular machine, and suddenly in the last 5 minutes if I find that there has been a huge inflow of packets from that machine, immediately the antenna of that particular detection software will basically sort of rise, and then it will start suspecting that this particular machine from which this traffic is getting generated is possibly compromised and immediately block all the traffic, right. So, this will sort of ensure that this particular server and maybe the remaining servers in this particular network is completely protected. So, likewise I could actually have something like load balancer which is also installed, which could basically sort of balance the load that is actually coming in onto a single server among a set of mirrored servers, so that one single server does not go down, and even if one server goes down I do actually have other servers which could actually handle the load, right, as compared to having only one single server which then becomes a single point of failure if at all the attacker is successful in bringing down that particular server. Thank you.